Hello guys, today in this video tutorial I will be introducing a new sensor, that is ADC081C. Now to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this sensor as you can see on my screen. And here we go. As you can see, it's a 8-bit 1-channel high-speed ADC, analog to digital converter, and as you can see these are some of its more prominent features. As also, you can purchase this sensor from this website, from here. I will be interfacing the analog to digital converter ADC081C with a Raspberry Pi and a Java code, and to get that code, let's go to the source tab, and here comes the Java code sample. Now you can download this Java code sample as a file from here, and also you can have the code from github.com, and the repository there is Control Everything Community. Now what do we require next is to make some hardware connections, and let's see what we got there. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack, and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter just like that, and you can have on the USB port. Now next we require our sensor, that is ADC081C, and this here is our connecting cable. Now to make a connection among the sensor and the cable, we make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly this rule has to be applied to the I2C shield. So as we are done with the connections part, now our requirement is of the explanation of the code, so let's have it. Now coming to the interfacing part, the first step is to log into github.com, and here we have to search on for the repository, that is Control Everything Community, which you are able to see on my screen. And here comes the sensor which we have to search for. It is ADC081C, and here comes the Java code. Let's have a look over the instructions we need to fulfill first. First of all, we have to download and install Pi4j library. It's on to the Raspberry Pi, and this pi4j.com is the link which will help us to install and download the library. Please note down carefully all the relevant instructions and whatever you need to follow. Now as you can see, this is the command to compile the Java code, and this is to run the Java code. Now note them down carefully and get back to the code for the Java. As you can see, it's a .java extension file. Now in the GitHub code, as you can see, we have imported some of the libraries, and we have created a class, public class named ADC081C, and in this part we are going to check the address of the device, bus.get device. It's 0x50. Coming to the writing section part, we are going to select the configuration register having address 0x02, and we are going to send or write the command for automatic conversion mode enabled, that is 0x20. After that, we are going to read 2 bytes of the data from the address 0x00, and it's the raw ADC MSP LSP, and there comes the conversion of the data, which is according to the guidelines and the formulas provided for the data sheet ADC081C. At the very end of our output, we need to display this output onto the screen, which is the raw value of the source. So as you can see, this is how the code looks like of the Java for the sensor ADC081C. Now let's see how it works. Now coming to the interesting part, that is to check for the practicality of this code, we have to copy this entire Java code as you can see on my screen, and we have to open up the terminal of the Raspberry Pi using an internet connection as you see. And here we have to create a new file as you can see on my screen, which is .java extension file, and after that we have to paste the entire code here, and then the next step is to save it. After that, this is the command as you can see on my screen, It's for the compilation process and the code is being compiled. The code has been compiled successfully. Now to run the code, this is the command, and as you can see, we have the raw value of the source, which is exactly 0. It means there is nothing connected among the terminals of this particular sensor, but instead when I try to connect a AA battery of 1.5 volt source, now when I run it can see the value of the raw value of the source changes, and it is a raw value which is 46, and it's almost constant because the battery is connected right now. So this is how the sensor works. Now let's have a look over the benefits, features and the applications of this particular sensor. The ADC081C is a low power monolithic 8-bit analog to digital converter that operates from a plus 2.7 to 5.5 volt supply. The converter is based on a successive approximation resistor architecture with an internal track and hold circuit that can handle input frequencies up to 11 MHz. Due to these variables and a lot of features, a lot of applications are dependent on this sensor, which includes system monitoring, peak detection, portable instruments, medical instruments and test equipment. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.